Welcome back. Let's continue on with the completion of our command set interfaces conversation. The other day we had this point where the command sets could be declared externally and their public functions be broadcast to our internal database. So we have many DLLs doing this. But what it wasn't doing is, at the end of that process, going back through and finding the functions that were unknown for each command set. So if you have a bank command set, for example, and you need to load data off the device, I could write the loader myself, but I'd rather just use the one I've already written for the read memory command, for example. And so in this case, you would have you'd tell it that you want to use an external command set of the read memory function from the file system. And when the program is started up, it would run through and look at all the DLLs that are attached, find the functions they're willing to export into this public database, then go back through and locate the read memory function from the file's DLL. It'll get the pointer to that and then write that back into our DLL for us. So all of that's a big convoluted mess, but the back end part of that was completed probably the session after I was last talking about this, but it wasn't working properly. There was a bug in it. Now, I'll show you what the bug was in a second. But we'll look at this testbed demo. Go to console, hit interface. Now, it's revealing what command sets that are added to the database, what functions are added to the database, what the address of these functions are in memory within this DLL. So the file system, we've got one here for our test banks. These are mock-ups basically. File system has one there for delete file. We've got a basic math one. Now, I was testing this out with a secondary function, and the function tallies up 3 integers. Pretty terrible. In order to do that, it has to call a function from basic math, which is add integers. So this function, this add ints function down the bottom here, which is giving us a result of 60 because we're adding 10, 20 and 30 together. Just have a look at that code. Yeah. Well, I've called the function sum 3 ints, 10, 20 and 30. Now, the actual function that we're calling on the C side of the DLL, we'll have a look at that. There we go, pb sum 3 ints. So we're passing in 3 integers, well 3 longs in C terminology, and we're doing something weird. We're checking if this add ints is not equal to 0. If it's not, that means that this function pointer was actually set up for us, or it's been filled in. And then we call this add ints as if it was a function. So here we're adding a pair of integers, getting the result, adding the result plus another integer. Now, in terms of addition, it's the worst thing you ever possibly do, but it is showing us that when I call this function, the DLL is resolving this address here for us. Now I can prove that if I remove the name down here, right? So in my get external function here, if I change the name of add ints to something else, some garbage after it, do a quick recompile, go back to PB, we'll run this thing again. Now it won't be able to find that function because it's not declared, and our result of sum ints is now 0 because this function actually doesn't have it hasn't been resolved at load time, so it couldn't find it. Therefore, when we call the sum 3 ints function, it's unable to do this add integer operation in it. So all of this convoluted mess to get to this point. Now, of course, we're not going to use it to do something as trivial as like adding integers together. That's ridiculous. But we will use PB's own commands in other command sets to make it much easier to write, bigger sets of commands. The only reason why this wasn't working was that there was a string comparison problem. So in the external function here, the load process is calling the getExternal function from each DLL, and it just calls them in a loop, asks them, what's the name of the function you want to find, and it sets an address of where this is meant, where the location of this function is meant to be written out to. Now, this first one here is actually an add command. It really should be change command actually. So it should be change to tell it that I want to search the next function down here from the basic math command set. That was working, but there was a bit of code to do with solving where this slash is that was relying upon a find character routine. I've actually fixed this now, but before it wasn't returning what index of the character that you were looking for, which is just a simple for loop. It was returning the character before that, and it would send all the logic below it into chaos. It meant that if you had those, it just would not work properly. So this is the getExternal function. This is part of our interface library. So this lives inside PB, not inside the libraries. We're calling it from our loaded libraries, checking to see if our getExternal function exists within the library. If it doesn't, no skin, we just ignore the rest of this crap. So it's probably just a normal DLL, or a DLL that's not written to be a command set within PB. But you could add that functionality there if you wanted to any DLL, and then internally you can use the same mechanism to call your functions. Here we're doing a bit of well, I'm not happy about this loop actually. We've got a fixed length loop to, where I'm assuming that we'll never have any more than 2048 external function requests. I don't believe you'll have more than a couple, but I've set it pretty high, so we should never overflow that. And it means that the loop will end. Otherwise, it might be possible that the loop could be jimmied and sort of continue, get stuck, We're setting our structure up, we're calling our getExternal function from the DLL, and we're querying where the location of the return string is. If it's a null string, we go, okay, we've hit the end of the declared strings, let's get out of this loop and go back and load the next DLL and do those things. Doing our find character, and then checking, making sure it's at least one character of length, making sure it's not too long, because the buffers internally are like 256 characters in size. I don't want to overflow them. A bit lazy really. We're forcing a null term, so here I was a bit concerned about the null term stuff wasn't working properly. That's what I thought the problem was initially. Grabbing our string to first character, comparing if this thing is equal to that, to the add command, the prefix really. If it is, we adjust the pointer, add this as a command set, and if we add it as a command set and it already exists, then we'll get an index, the index of it. This is for debug purposes actually. We don't really need that anymore. The other syntax is that you can have the command set and the name in the same string. So you can have like this, you can have sort of, banks and then, create bank. So this deals with that, finds where this slash character is. If it's within a legal length, we grab, we find the command set by name on the left of where the slash character is. The banks function, if it if it finds that, it should return the command set index. Then it should modify where this string pointer is pointing to within the buffer, and then just try and add it as a function to that set. So when we do this, we're actually changing the current command set. So yeah, it means you can sort of have these stacked up in order. So if you want to change the banks command set, then the next addition might be, you don't need the banks. You can just go, well, just find me delete bank, thanks. Delete bank. And off it would go. Anyway, a bit of messing around, it does actually work. It's not the cleanest solution. I might go back and refactor some of this. Given I've literally just cut and pasted the two things together. Yeah, the get public and these are the same basic code, except the get external has to do a bit extra than its this little friend over here, but that's okay. There we have it. Let's restore that code to what it was doing before. Declaration up here. Add ints, do a recompile, thank you. So it's solved now. There's probably some underground ones still in the code. It hasn't been tested that much, and the process needs to be externalized and dropped into, you know, other libraries to really test it properly. But so far with the tests what I'm doing here within the little test bed are working, so I'm pretty happy with that. Go back to here and view in amazement how it can add three integers together. Voila. Stunning, eh? Stunning. All of that to add three ints together. Who would have thunk it? I'll get to another sort of thing I do like about this, and you may not have noticed, is that if we have our command sets declared within linked DLL blocks, right? This would be, you know, this is obviously it's mock-up. This would pull in the banks library command set, and there would be declarations in here, you know, create bank. It's highlighting these things here because it thinks they're internal commands. It's the index, isn't it, and the size. There's an alias to what this function is actually called inside, you know, inside this banks DLL. Probably, you know, pb create banks or something. Yeah, it doesn't return anything, but it might have returned integer occasionally. Now here's something that you may not have expected. When we link external functions like that, we can actually use call. I can't do it with this actually. Well, I'm not going to be able to run this because this DLL doesn't exist. But let's pretend. Now I can do something weird with this. I can go call function. I can go create banks index size. So once all of these things here are declared as linked DLL blocks, as we've shifted across from the internal mechanism to an externalized mechanism, you'll be able to treat these internal commands as if they're your internal functions, which means you could use call function to actually call an internal command, which is pretty cool. You know, because you could have, you know, a string this function or something. I don't know. Create banks. You could do the same thing here. On the surface that might not seem like a very useful thing, but a lot of times it can help eliminate things like having to code certain things into our program. Like if we wanted to have a little runtime in PB at the moment, you'd have to have sort of a select block, have like an opcode here. I do it in strings, sorry. I have like a passing in a string, have a case in here, or have like, create bank would be an option, and then inside here we'll call the function create bank, and then do our index, whatever our index and size was set to previously. Delete bank, I'll have another one. So this mechanism here would kind of emulate what this is allowing us to do up here. We still need to, if this function has different numbers of parameters than the delete function, we need to call a separate one. But those things are solvable. We might have a little table where we can look up which version of the call we need to call, and then just pass it through and call the thing we need to call. But that gives you even greater freedom to do, well, I guess in some ways probably hang yourself, but no, it's write code that's very hard to follow and very convoluted to maintain. But to do things that are just a step beyond where we were before. To move towards something that's, you might want to have some code, some actual PB code, or like script code for your game that calls actual functions internally. That's one way to go about doing it. And it's more involved than just doing this, but the actual process of calling the function by name is something that you could do just like that. Now, you could do this currently, but you'd have to go through and we wouldn't use p subs. Wrapper, create bank, index, size, end p sub. So we roll a user function, in this case a p sub, which is a protected subroutine, for every function that we want to expose. Delete bank here, go back here, delete bank index. Then here I could do, I couldn't call the command directly from within PB today, but I could actually call this wrapper. So you could go, wrapper plus command name. There's an underscore there, isn't there? Now, if we called the delete, it's going to break because the number of functions we're passing, the number of parameters is incorrect. To make it simple, you probably could just pad these things, have a pad there, and now you could just choose between the two. Command name equals create bank. Oh, well, we'll just set that up. I won't do the bank creation, but we'll just do a couple of prints. rid of this other bit of code. So weird looking wrapper. Have a wait. Wait key at the bottom. Let's see how we go. Call function can't locate this function. Missing a C, that's why. So we call create bank. We didn't pass anything in, so I'll put 1,000. I'll put, bank 10, and we want this thing to be that many bytes. So what if command name was an array? Oops. Delete bank, dim command name, have at least 2. For loop equals not to 2. Here we actually should check to see if function index. What we're doing there is we're doing a search. We're checking if this function exists, so as to try and stop it from not crashing. Alright, so we're stepping through. We want to grab our command name from the array. So first loop through we're doing create bank, second loop through we're doing delete bank. So here we go. Can't locate wrapper. So this is what we want there. That's better. So we've got create bank, and we're calling delete bank. So we've called those two things call those two operations purely on following the order they appear in our array. Now the parameters you need to have a way of grabbing your parameters. But if this is a string, for example, you could do, you could have a string in here somewhere, and now we're sort of cutting and pasting or deciphering what's in this string, getting the function name out of the thing. If you know this has a certain pattern to the call, you need to break all this stuff down. I won't do that now. I'll do that in a separate example some other time. But the point I was trying to get to before is if we have our internal commands wrapped like that, they can be called by name within your program. It's not going to be super easy, but you can do it. Pretty cool if you ask me. I think we'll leave that there, and I'll see you next time. Happy coding. Bye.